Have you ever stopped to think about what's actually happening inside your PlayStation? I mean, it's way more than just a box with some circuits. It's a fantastic story of science, of engineering, and, yeah, even a little bit of corporate betrayal. So let's dive in and unpack the incredible architecture behind one of the most iconic consoles ever made.
You know, it's kind of wild to think about, but back in the late 80s, Sony wasn't even in the gaming business. They were actually partners with the undisputed king of the hill, Nintendo, working on a CD-ROM add-on for the Super Nintendo. But then, in a move nobody saw coming, at the 1991 Consumer Electronics Show, Nintendo publicly backed out of the deal. They just walked away, leaving Sony high and dry, and completely humiliated on a global stage.
And right there, that's the moment everything changed. Instead of just packing up and going home, Sony's team asked this incredibly bold, super risky question. A question that would kickstart a multi-billion-dollar project and literally reshape the entire entertainment world. See, the PlayStation wasn't born out of some grand 10-year plan. It was born out of a reaction.
So Sony's first big challenge was, how do we make a splash? They decided to bet the entire farm on mastering real-time 3D graphics, a concept that for a home console back then was basically pure science fiction.
This was a massive shift in thinking. Before this, games were made of flat, 2D images called sprites. You can think of them like little paper cutouts moving around. But the PlayStation? It literally sculpted entire worlds out of these mathematical shapes, polygons. Every single character, every car, every mountain was built from thousands and thousands of these tiny little triangles.
And this is the secret sauce that brought those polygons to life. Just imagine the PlayStation's 32-bit RISC processor as a high-speed calculator on absolute steroids. It was just constantly crunching these incredibly complex equations. We're talking linear algebra, trigonometry, telling every single polygon where to move, how to rotate, and what size it should be, all happening in the blink of an eye. It was pure mathematics creating these brand new virtual realities.
But here's the thing about 3D graphics. They take up a ton of space. And that is exactly why Sony's decision to go with the CD-ROM was such a game changer. I mean, look at that number, 650 megabytes of storage, when a typical cartridge might hold, what, 16 megabytes? This wasn't just an upgrade. It was a completely different universe of data. It changed everything.
So what did all that extra space get you? Well, with all that room to play with, developers could suddenly pack in full-motion video cutscenes and beautiful orchestrated music scores. You combine that with the mind-blowing 3D graphics, and suddenly, playing a video game felt like you were directing and starring in your very own interactive movie. Okay, so the first PlayStation was a runaway success. And that success? It sent Sony's ambition into absolute overdrive. This next era would give us the single best-selling console of all time, but it would also create one of the most notoriously complex and difficult engineering challenges in gaming history. Just listen to that name for a second, the Emotion Engine. And I'm telling you, that was not just some clever marketing. The PS2's processor had this radical new architecture designed to juggle a bunch of different tasks all at once, kind of like how a brain works. The goal wasn't just to make graphics prettier, it was to actually simulate life itself, from the tiniest animations on a character's face to the way a piece of cloth would realistically flutter in the wind.
And the result? Oh, it was stunning. Games on the PS2 just had this incredible sense of realism and life to them. Plus, because Sony brilliantly decided to include a DVD player, the console morphed from just a gaming machine into the absolute centerpiece of the living room. It was the all-in-one entertainment hub everyone wanted.
And then came the PlayStation 3. At its heart was the Cell processor, which was basically a supercomputer in disguise. Seriously, this thing was so powerful with its unique parallel design that the US Air Force actually bought over 1,000 PS3s just to link them all together for scientific research. But all that power came with a huge catch. It was notoriously, unbelievably difficult for game developers to program for. Now, to feed a beast like the Cell processor, you need a whole new way to store data. So, enter the Blu-ray disc. By using a blue-violet laser, which has a much shorter wavelength, they could cram up to 50 gigabytes of data onto a single disc. That's 10 times more than a DVD. And they needed every bit of that space for the high-definition assets the Cell was capable of rendering.
So the PS3 really was a paradox, right? On one hand, it could produce these absolutely breathtaking visuals that were light years ahead of anything else out there. But on the other hand, that power was so complex, so hard to unlock, that it really frustrated developers. And that struggle, well, it definitely slowed down how quickly people adopted the console in those early years.
You know,
Sony learned a really critical lesson from the PS3. Having immense power is totally useless if no one can actually use it. So for their next chapter, the whole focus shifted. It became about efficiency, about being developer-friendly, and ultimately about waging a war against the final frontier of game design, time itself.
Look at this. With the PS4, Sony did a complete 180 on their philosophy. They ditched that complex custom cell processor for a simple, familiar, PC-like architecture. They unified the memory so the CPU and GPU could share information instantly. The goal wasn't just raw brute force power anymore. It was about usable, efficient power that developers could get the hang of almost immediately.
Now, this change in philosophy opened the door for incredible new techniques, like physically based rendering, or PBR. This is the real science behind why materials in games today look so authentic. So instead of an artist just painting a surface brown and calling it wood, PBR actually simulates how light physically interacts with that surface, its roughness, its reflectiveness. It's the reason metal actually looks like metal, and why wet pavement realistically reflects streetlights. It was a massive leap towards true photorealism.
And that, of course, brings us to the PlayStation 5. And while, yeah, it is an incredibly powerful machine, its single biggest innovation isn't really about the graphics or the processing. It's about speed. Sony's engineers launched a direct assault on the one thing every gamer on the planet hates, the loading screen.
Get a load of this number. 5.5 gigabytes per second. The custom solid-state drive inside the PS5 is so ridiculously fast that it completely changes how games can even be designed. Data can just be yanked from storage almost instantly, essentially teleporting game assets right where they need to go and completely eliminating those old-school bottlenecks.
Now, you take that insane speed and you combine it with amazing technologies like ray tracing, which simulates the actual physics of how light bounces around a room, and Tempest 3D audio, which models how sound waves travel and hit your specific ears, and what you get is something entirely new. You get a genuine sense of presence. And really, that's the ultimate goal of the PS5's entire architecture. It's all about tearing down the barriers between you and the game world. No more loading screens, no more obvious graphical tricks, just this seamless, instant immersion that makes you feel like you are physically there. So when you look back at this whole journey, from a broken business deal all the way to the bleeding edge of modern technology, you start to see this really cool, consistent theme. You see this incredible process of science becoming art.
It all started by using the elegant, abstract rules of linear algebra to build the very first 3D worlds on the original PlayStation. Pure, raw mathematics was being transformed into these sprawling, imaginative landscapes for us to explore.
And then, that idea evolved into something deeper. By simulating the actual laws of physics, things like gravity, momentum, the way light behaves, developers could create characters that moved with a believable, lifelike weight. They could convey emotion not just through a story, but through the very physics of motion itself.
From a risky bet made out of defiance to a global platform for entertainment, the story of the PlayStation is really the story of turning silicon and code into shared experiences and digital art. And it leaves all of us with one really exciting question to think about: what comes next?